The following examples deal with solving an equation for a specific variable. Equations that contain one or more variable are known as literal equations. So in the first example, it says x times the quantity y plus 2 equals z, and we want to solve for y. Now there are two ways of doing this type of problem. We're going to do the most common way by students first, which is whenever you see a number or term outside parentheses, usually bring it in by distributing. So let's try that route first. We have x times y plus 2x equals z. Now the whole goal is to solve for y, to get this variable all by itself. And what we do is we apply the same techniques we did when we solve an equation in just slope-intercept form, or we solve a regular equation. We get rid of any addition or subtraction first, and then we get rid of any multiplication or division. So the first thing I'm going to do is I'm going to subtract 2x from both sides. That's going to allow me to cancel out 2x. So all I'm left with on the left side is xy. And then I have z minus 2x on the right side. Still want to get this y by itself. So I'm going to get rid of the multiplication that's going on by performing division. So I'm going to divide both sides by x. Now when you divide the right side by x, you have to divide both terms by x. That allows us to cancel out the x here, because there's an x on top and the bottom. So now we have y equals. That was our goal, to get the variable y by itself. So now what we need to do is simplify this right side. So you have z over x minus, now you have 2x over x. So since you have an x in the top and the bottom, they cancel out. So it's z over x minus 2. So this route allowed us to take the normal path we're used to, which is when you have a term outside parentheses, you bring it in by distributing. The next route that we're going to use is a little bit different. It involves some thinking first. So let's slide this one over. Rather than distributing the x first, if we look, we're trying to solve for y. And right now this y is contained in this parentheses, this object. It's protected by these parentheses. And these parentheses are being multiplied by x. So rather than distributing the x inside, which is multiplication, I can actually divide both sides by x. That allows the parentheses to be isolated and give me y plus 2 equals z over x. Now if I want to solve for this y, all I have to do is subtract the 2 from both sides. So it cancels, and I get y equals z over x minus 2. So we start to see in this example, there are sometimes more than one approach to isolating the variable. Either way is acceptable. If we look at the next example, 5a minus 6b equals 9, we want to solve for b. This one you can relate very similar. You can relate to the idea of slope-intercept form. You have two variables, you want to solve for one. It's set up very similar to standard form for a linear equation. So if I want to solve for b, the first thing I'm going to do is I'm going to subtract 5a from both sides. That way it cancels, and I get negative 6b equals negative 5a plus 9. And then I'm going to divide every term by negative 6. The negative 6 cancels, so b equals, now remember a negative divided by negative is a positive. So I get 5/6 a. And then when we simplify 9 over negative 6, a positive divided by negative is a negative. And you get 3/2. So b equals 5/6 a minus 3/2. So that is the idea of solving literal equations, equations that involve more than one variable. A technique to use is to try and relate it to something you're confident with, and by the time you're in Algebra 2, solving into slope-intercept form is something you should be good at. And so relate how to approach the problem to those techniques.